Good morning, grade 8s. So we are going to spiral back a little bit to a concept that we didn't cover as well as I would like. And I want to make sure that you're in on this as an essential outcome. So we're going to talk about square numbers, roots, and then finally go on to Pythagorean's theorem. And we have covered some of this, but so this is going to be a review, and hopefully you'll nail it when you do your year-end assessment when you come in June. Still wondering what that's going to look like, but I'll let you know when I know more. So square numbers and area models. Let's go to first a basic lesson here on what is a square number. So squares and roots. This is one of those concepts where it's complicated at first, and then when you get it, you've got it. So let's take a look at what these are. First, we know that if we have a square and it measures 4 on one side, we know that a square means all sides are equal. So 4 squared means that the root of this square is 4. What would the area be? So that would be, of course, 4 times 4, because you remember way back when you were in grade 3, you would do this when you would multiply things. And you'd say, well, how many squares are there? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares. And then eventually you figured out, oh, wait, that's just 4 times 4. And you went, duh. And then after that, you didn't have to sit there counting each square with your fingers. Well, this is how 4 squared is written. So 4 squared, this is an exponent. And an exponent means how many times you multiply it by itself. Now, the basic thing I've shown you in the past is this. Here's our happy square again. Oops, I was 4 by 4 there. That is a 4 by 4 square. Well, that would be 4 times 4, which is equal to 16. Well, what if it was 4 cubed? Well, this exponent says I need 4 times 4 times 4. Why 4 times 4 times 4? Cubed means if we turn this into a cube, pardon me, if I had 4 as a cube and we counted how many cubes there were, we would have 4 times 4 times 4. 16 times 4 is 64. So this is how our basic exponents work. So let's go back to squares. What is 2 squared? Well, 2 squared is like this. If the root, or the bottom of the square, is 2, then the square itself would be 2 times 2, which equals 4. 1, 2, 3, 4. 3 squared. Same. 4 squared. And I think you guys get it, so I'll just stop there. All right. So we're going to start really simple. We're going to go into 1.1 in the textbook. You're going to fly through it because I think you already have this. So what I did this week is I gave you 1.1 and 1.4 because we're kind of skip jumping through it, seeing as it's review. So here it explains 1 squared, 2 squared, 3 squared, 4 squared. No probs. Let's look at an example now. All right, when we multiply a number by itself, we square the number. Like 4 squared is 4 times 4 is 16. That's what we already covered. This is what I was writing down. So for example, here is a square number of 7 times 7. So we have 49 squares. And you can also do the inverse. This one is 169. So what times itself equals 169? 13 times 13. So if this is an area of 169, I can figure out the edge. So let's take a look at an example of that. If I gave you a square and it had 81 centimeters squared, that's the square. Can you now find the, here I'll get it to focus on my hand, hold on, there we go. Can you find the root? So the root, we write it like this. This means if I have a square that's 81 squares, what is the root, or what is the measure of one side? So basically I have to figure out what times itself equals 81. Well, you probably already have it in your mind. The square root of that is 9, because I know 9 squared equals 9 times 9 equals 81. So if 9 squared is 81, then the square root of 81 is 9. Now at this point, you're probably going, hey, I get it, Mr. Ewert. Cool, cool, cool. If that's the case, awesome. Move on. Let's go. If that's not the case, I'm going to move on now. I suggest you watch the Mathematics video that I've also put in this post because it will help you out. So let's go back to the assignment. These ones, if you are in the lesson so far, it's going to be easy peasy, and then you're just going to have a quick review. So for example, it says match each square below to its area. So you see this one? The area is 4 square units. So which one is it? It's 2 units times 2 units, 4 square units. Okay? I think we've probably done this one enough. So let's move on. Let's take a look. Oh, wait, let's look at the last part though. This person has a floor that is 144. What's the length of one side of the room? Well, by now you figured out if you have a square that's 144, then the root is finding out how much on one side. That's just like what we did here. So what if I had a room that was 144 and it's square? We'll say meters squared, okay? Then what is the root? So what is the root of 144? Well, you got to figure out what times what equals 144. And you may have already figured it out. It is 12 times 12, which is 12 squared. So that means 144, the root is 12. That is correct, because 12 times 12 equals 144. I know this squared equals 144, and the square root is 12. Now here's something you're going to find somewhere in your questions. Check this out. 12 squared, what's the root? This and this cancel each other out. Just thought I'd throw that in there, because it's going to happen. At some point you're going to see it. All right, let's go take a look at 1.4 now. Estimating square roots. Okay, so you're going to find that sometimes square roots don't completely line up. So let's take a look at an example. Okay, one moment. All right, so for example, it says, let's estimate the value of the root of 20. Well, if I gave you, if I gave you 16 or 25, that'd be really easy. Like if I said, hey, here is 16 meters squared, what's the root? You'd go, oh, no problem, Mr. Ewert. I think it's 4, because 4 times 4 equals 16. And you'd be right. Well, if I said, well, then what's 25 if it's an area of 25? And you'd probably go, oh, well, the root of 25, I guess that'd be 5, because 5 times 5 equals 25. You'd be right. But if I said, okay, what if I have a square and it's 20 meters squared, which means that the side measures into a decimal? Well, geez, I don't know, Mr. Ewert. Now, you could just say, well, that's okay, Mr. Ewert. I have this, and I can just hit the square root button. Nice try. We're estimating, and we need to find an estimate of that. When you're doing an estimate like that, I'm going to give you a number line. 1, 2, 3, 4, 5. I know that it's more than 4 because it's more than 16. But it's less than 5 because 5 squared equals 25. So that means it's somewhere between 4 and 5. But where between 4 and 5? Well, 20 is 4 more than 6, but 5 less than 5. So it's probably close to the middle, but a little over here. So I don't know, maybe 4.4-ish? I think that's pretty reasonable. Now I'm going to go to my calculator. I'm going to check it out. All right. I'm opening the calculator function. Let's just see how our video is doing. Okay, 5 minutes left. if I take my calculator and I turn it sideways, oh, I think my phone is, I told it not to go sideways, and I turn it sideways, now I get a little square root button in those extra functions, and there it is, that little check mark looking thing. So I'm going to go 20 square root equals, oops, I did it in the wrong order. I'm supposed to go square root 20. Square root 20. Oh, shoot, I think you're seeing the opposite. Here we go. Square root 20 equals 4.472135954999, blah, 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 blah. So 4.47. Was I close? Yeah, it was pretty close. I could have been closer, but all I had to do is first I had to think, where is the root of 16? Where is the root of 25? Where is the root of 20 going to be? About there. So I know it's about 4.4-ish. All right, let's go back to the assignment. So you can see that 1.4 is much more complicated. Once you've got the meat and potatoes from 1.1, now you're going to your estimates. And it shows you right here what I was just talking about. So you can go over that yourself. All right, so let's get another example. 96, whoops, sorry. Which whole number is the root of 96 closer to? How do you know? Okay, let's make a quick list. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6. All right, just hold on. All right, we are trying to find the square root of 96. I know the square root of 81 is 9. I know the square root of 100 is 10. So it must be between those two numbers. So here's the square root of 9 and the square root of 10. Now I know the square root of 9, or 9 is the square root of 81. 10 is the square root of 100. So where is the 96 going to go? Well, if this is 81 and 100, probably pretty close to this end here. So I'm going to guess pretty close to there. An estimate, that would be like 9.82, we'll say. There's my guess, 9.82. Now I'm going to check on my calculator and see how close I am. Let's see, turn my calculator sideways and go square root 96, 9.797, so about 9.8. Well, I was pretty close there with my 9.8. All right, so there's your other example, and you've got your questions lined up. I expect you're going to have some questions. I hope you do, and I hope to see you in study hall. I really appreciate those of you who have been coming to study hall and asking excellent questions, and never be afraid to ask a question. Remember, being smart, it's not about what's in your head, it's about what you're doing with it. And if you're asking a question, you're doing some pretty smart stuff. I really look forward to seeing you in study hall, and I hope this lesson was good for you. And if not, you can also go to the Math Antics video that I posted. Cheers.